All right, so rings. Usually when you say rings, someone thinks of Saturn's rings. However, all four Jovian planets have rings, and they're all around their equators. And the materials in these rings can go from tiny, tiny, tiny particles all the way up to mini moons, which we call moonlets. So how did they form? Well, we think they formed when a moon was destroyed. Got too close to the planet's gravity ripped it apart, and it just started circling the planet as pieces. So whatever the moon is composed of, that's what you have in your rings. Okay, so let's talk about the famous ones, right? Saturn's rings. The rings go from 7,000 kilometers from the equator, so the equator, 7,000 kilometers rings start, to 80,000 kilometers. So from 7,000 to 80,000 you have rings, right? This mileage would be 4,200, right? So equator, 4,200 miles out. And then from that all the way to 48,000 miles. Those are how far the rings can go out. Okay, so that's huge. However, thickness is only 10 meters. That's 32 feet. Not very thick considering miles across. And most of the rings is composed of water ice. 99.9% of the rings are water ice. And again, size, well, a centimeter, so tiny particle, to 10 meters. So Galileo was the first one to observe that Saturn had these rings. He didn't know what they were. He called them Saturn's ears. Now this is back in the 1600s, so it's pretty impressive that he even saw that. Then Huygens, about 40 years later, said, hey, wait a second, I think this goes all the way around Saturn. I think it's a ring. And so that's when we discovered the whole ring. Now, he thought it was solid. It wasn't until about 20 years after that that Cassini discovered a gap in the rings, which is now given his name, the Cassini Division. So there's three different rings we can see from Earth. And in our creativity, they're A, B, and C. So A is the furthest away from the planet. Okay, so the furthest away from the equator. And it's the second brightest. It has a little gap in it called the Encke gap. And you can see it there in the picture. And then there's a division, the Cassini division, the big division that we can see. And comes the next ring, B ring. It's actually the brightest ring. So we can see the A ring, which is the second brightest, B is the brightest, and then we can see the C ring, which is actually closest to the planet and is kind of translucent and a little bit more difficult to see. Now there are other rings, D, E, and F. These guys you can't see from Earth. You have to get out into space, so we didn't know they were there for quite some time. So an interesting thing is that the rings we think are young. We think they're only 50 million years old. Okay, how so? Well, could have been from, like I said, moons that were torn apart by gravity, and so they had to get close enough to be torn apart. So that would have been not as long ago as the planet being created. Could also have been fragments, meteorites, asteroids that just got too close and got taken up into the ring, and round they go. We don't really know which of these is true or if it's a combination of both. We're not sure. Now, we do know Triton, and I told you about Triton. That's Neptune's moon. Right? That's the one with the liquid nitrogen geysers, where we're all going to have ice cream. Yeah, so that one is actually coming too close to Neptune, and eventually it will become a large ring comparable to Saturn's rings. Another interesting thing about Saturn's rings is the seasonal change. Just like we can see phases, we can see kind of a phase of the rings, if you will. Basically, as it goes around the sun, as Saturn goes around the sun, we can see different parts of the rings. So sometimes we'll be able to see the full ring, sometimes we'll be able to see kind of like edge on, and so we can only see the edges of it instead of the front face and back face. This is probably why Galileo thought they were ears, and then later on they discovered that it was a solid, quote, ring, and then they ended up seeing the division and blah, blah, blah. So again, Saturn's rings are complex, and as we study them more and more, they may have only formed a few 100 million years ago, maybe even as soon as 50 million years ago. If you're interested, there are some conspiracy theories out there. Not that I'm saying they're true, because they're not. But that aliens have made these rings, or that there's alien ships hiding in the rings. It's actually quite ridiculous, but the information is out there is pretty funny and a little bit disturbing. All right, so I kind of hinted at the fact that if something gets too close to the planet, it will rip apart by gravity. This is how, okay, this is the Roche Limit. That's what it's called. So this is how we think rings form. There's a moon, satellite, something approaching a planet, in this case Saturn, and the tidal forces, the gravitational tidal forces, are going to start stretching that moon or whatever it is. And so you can see in the picture it looks round, right? It's got enough gravity to hold it all together. Well, as it's approaching the planet's gravity is much, much greater, so it starts to stretch it at the one side that's facing the planet. Until finally it can't stretch anymore, and then it just snaps into a whole bunch of pieces. And those whole bunch of pieces get taken up into the planet's gravity, and they orbit the planet, hence you have a ring. So technically the Roche limit is defined as the minimum distance away from a planet in which a space object will be torn apart. Now, what is this minimum distance? It's about 2.5 times the planet's radius. Okay, so don't get anywhere near 2.5 times the planet's radius because you'll be torn apart. Okay. Now, there's a certain limit, size limit, where this does not apply. Because in the case of the nice little round satellite there, gravity is holding it all together. However, if it's small enough, and by small enough I mean small little pieces, it's not gravity holding it together, it's actually the I want to say pressure, I'm not sure that's right, but it's the force in between the atoms that are holding it together. And so gravity can't overcome this force, so it can't rip it apart. So, and again, that would have to be pretty small to make sure that it's not gravity, but it's actually the forces of the atoms themselves. All right, so we knew that there were rings A, B, and C on Saturn's rings with this Cassini division, and we wanted to get a closer look, right? That's what we do. So we sent Voyager out. Well, it looked at its rings and it's like, well, wait a second. These aren't like A is not a solid ring and B is not a solid ring and C is not a solid ring. These are actually ringlets. There's tens of thousands of ringlets that make up these rings. And, well, think about that. So it's not solid. There's basically bunches of little tiny pieces of gravel or bigger boulders or whatnot that are circling the planet. So what keeps them all together? Well, sometimes they don't. Sometimes they spread apart a little bit. Sometimes they come together a little bit. Depends on their orbit, their gravity, and a whole bunch of other physics. Right? So there's actually a whole bunch of gaps in these rings. and 20 gaps that we know of that, well, we would consider a gap. Not quite sure on the boundaries of that, but whatnot. There are moonlets, like I said, 10 kilometers across, 20 kilometers across. Not usually much bigger than that because it'll be ripped apart. And then there's little tiny particles, the sweep up particles. Okay, so what is causing this division between A and B, this Cassini division as we know it? Basically the gravity of one of the moons, Mimas. That's the one that looks like the Death Star. So the moon is actually deflecting the ring particles one way or the other. It's clearing out its path. That's what's causing this division. So here's A, B, C, D, and E, and F. A, B, and C are the ones that we can see from Earth. D, E, and F, we can't. It just gives you some information. It's straight out of your textbook. F is kind of interesting. You can see a picture of F there. And it doesn't look nice and straight, right? You think of a ring, you think of nice and straight. This kind of looks like it got bashed in at different places. It was discovered by one of the space telescopes, Pioneer, back in '79. But it looks like it has kind of a braided appearance. Yeah, it's very thin. I don't know why, but apparently back in the '70s, maybe sheep herding was the thing. I'm not familiar with that, but anyways, they looked at this and they're like, oh, that kind of looks like sheep herding. It's the way sheeps gather in a flock. I don't know, but this is kind of what stuck. And so the analogy is they've got these satellites, like Pandora in the picture there, that are kind of keeping all of these clumps of rock together in this weird braided pattern. And so they're calling them shepherd satellites because to them it looked like, instead of rocks, they're like little sheep. Again, I'm not sure. It's just an analogy that we got stuck with. And they're actually still called shepherd satellites. D has some faint rings, few particles, very dark. Can't be seen from Earth because they're dark. E is actually just made out of dust. So very hard to see from Earth. It's kind of a nice picture of it there. So this is one of my favorite pictures of Jupiter. You can see the banding, you can see that great red spot, you can see some white spots on it, but you can also see its rings. Right? And now obviously the rings are not as spectacular as Saturn's rings. Well, they're very thin, they're made out of dust, so really hard to see from Earth. The Voyager satellite was actually the first one to discover the rings around Jupiter, and here's a close-up of them, and you can kind of see how it looks dusty and fuzzy. It's inside the first moon, so the closest moon is still a little bit further out of the rings, so they're not as grand as Saturn's. Made out of dark rock and dust. Again, that's why it's really hard to see them. That's why it took us forever to find them. So, just a breakdown of the rings. Mm. All right, so in the '70s, again, we were able to find the fact that Uranus has a ring system. It's got 11 rings, actually, and as you can see from the bottom picture here, they're labeled in the Greek alphabet because Saturn had already used the English alphabet. They are very dark, they're narrow, and they're widely spaced, like between each ring, so they've got big gaps. However, they are still very thin. I have nothing really to say here except for the fact that I like that picture of Uranus. Again, you can see the rings. You can see some storms going on. So obviously this isn't visible light. This is some other light. I believe it's infrared. I'm not sure. Neptune's rings. And I love the top picture. It's like we have to block out the light from Neptune in order to see the rings. There they are. There's 4 rings. Narrow. 3 of them are narrow. One of them is kind of broad. Very thin though, kind of diffuse. And some of them are so thin in some places it's almost like, well, are you sure this is a ring? And again, they have the whole shepherd satellites. They've got some clumps in them, so they've got the shepherd satellites to kind of guide them along their way.